Hello, my name is Aitor Castellanos-Neri, and today I will be presenting my EEL 2161 project pseudocode for the spring 2025 semester for my programming with C class. So the deliverables, the first step is to make the pseudocode for part B, and this was user generated. So just going over the general instructions, my version of pseudocodes for specifically matrix multiplication. It's sort of written by like in a step-by-step type of guide, and it's much more legible. So it's like full sentences. So to first begin the process, we need to ask the user to enter the size of the rows and columns of the first matrix, and then subsequently we need to do the second matrix. For matrix multiplication to actually be possible, the number of columns from the first matrix, which I'll just say is A for now, needs to equal the number of rows of the second matrix, which I'll refer to as B. So if this isn't possible with the given inputs that the user gives, based on 1 and 2, there needs to be something in place in the code that tells the user that it's not going to be possible. And so I believe that some while or if statement would most likely be used here. So while A rows does not equal B columns, continue, or if yeah. So, but if the dimensions are all good, we can proceed to the next step, which is actually listing the elements of the matrices. So we list the matrices, the elements of matrix A and then matrix B, and then after that, we can save those, and we can actually create the code that makes the calculations that multiplies those. And then for this to actually be useful to the user, we need to display that result. And yeah, so this is more of my listing pseudocode. Here I made more of a general like things that I think I'll probably be using. So scanf will be used to obviously prompt the user for the rows and columns. As I mentioned before, we need a display that says try again if they don't match, or if there's some sort of error. We need to make sure we square that right away. Otherwise, we'll be getting results later on that the code will run, but it just won't be the correct mathematically correct answer. Then we'll be using INJ for the rows and columns, just generally using this for matrix purposes. So we create the matrices and let the user enter the elements. And then obviously we give the result of the actual multiplication. And then we display the result. And hopefully after all that, we get return 0. So yeah. So next we're going to be talking about Kramer's rule. Here is the pseudocode that I made for part D. So the user will need to enter the coefficients of the 3 equations and variables x, y, and z. And then they have to actually enter all the values for matrix A, which I just, for the simplicity's sake, made a 3x3 coefficient matrix. Just in this example, and then the result column B, which, you don't really have to worry about the rows. And then this is important. It's sort of similar to the first part B, in matrix multiplication, but instead we need to take the determinant. So from engineering analysis, I know that if the determinant is equal to 0, then we can just stop the process, and the system can display it to the user that it's not going to be. There's no point in continuing. But if it isn't, then 3 new versions of the original matrix will be made. So we have A1, A2, and A3 respectively. And this is done just mathematically by replacing the first, second, and third column with the result column, which is a B. And then the code will find the determinants of these new matrices, A1, A2, and A3. And then using Kramer's rules, the new found determinant over the original is equal to the coefficients x, y, and z. So here this visual shows it pretty well. So we've replaced the columns of x the first one, y the second one, and z the third one. And then we're dividing by d. Only if d is not equal to 0, which, as I mentioned before, if it is, we can display it to the user and say, there's no way to proceed. Yeah. So here's just more of that I said before, where I kind of made more of a Cody type of thing. So create the matrix of A will be I and J, and B will only be I, since there's no need for the rows. And then we can code an equation to calculate the determinant of matrix A. And then once again, if determinant A is equal to 0, there will be a unique solution. So we can just tell it to the user. Then we need to create a matrix A1, A2, and A3 by replacing columns. So once again, we just create that something to replace it. And then we code an equation to calculate the determinants. And then we could code actually Kramer's rule to find the results of X, Y, and Z. And this is done by dividing determinant A by determinant B by determinant C by determinant. And then that's our X, Y, and Z. So the chosen model I decided to land on was ChatGPT, just because it's very accessible, has multimedia capabilities of making and receiving pictures. Its reasoning is fairly well, and it has very structured writing. And if you enable the memory option, it's very personalized to the user. I would say some limitations of ChatGPT though is its short-term memory. You know, it often forgets a lot of the things that you talked about in your chat, or maybe it doesn't quite implement them in the way that you maybe have previously stated in the same chat. It can debug incorrectly. You know, AI just makes mistakes sometimes. It's not always up to date with current advancements. If you're looking for more current events or maybe current advancements that have happened in programming, anything like that. And then what I describe is very confident but wrong answers. So it'll give you an answer and it'll be very sure, you know, put an exclamation mark that this is right, but then it's very clearly wrong. So it can often trick the user. So here this is pseudocode. So obviously we have our inputs for rows, columns for matrix A, matrix B. This is just more of what I was saying before. If column, I guess it decided to use an if. So columns A does not equal rows B, then invalid dimensions for matrix, terminate function. So tell the user that. Here it's declaring matrix A, the rows and columns, and then the result of the multiplication. Here it's just saying, you know, prompting the user to know the bounds of the actual, you know, size of things, of the matrices, sorry, to be more specific, the columns or rows of A and of B. And yeah, this is just the multiplication that it decided to use. So once again, see a result for K columns, and then the result. Here's the multiplication, and then it wants to output the result matrix, and then it ends the function. So yeah, here's the pseudocode for part for D. So obviously, first we're declaring the matrix, as I mentioned before. I just wanted to give it like something specific, so I decided just the 3x3 was fine. So it stores the coefficients of the three equations. The right side hand constant. So there you go. Here it collects the user input for A, and then the user input for B. And then here it's kind of just saying the determinant of A. That function would be made, but pseudocode didn't really make it. And if it equals 0, as I said before, no unique solution. Here it's just talking about the replacements of the columns themselves, and here about taking the determinants of them. Here it's the actual Kramer's rule, so it's trying to divide it, the A1s with the determinants, and then it's outputting each of these, you know, X here, Y here, and Z, and then it just ends the function there. So my pseudocode is written much more like actual sentences, so they're different. But I guess the terminology used in AIs is more technical and correct. So if you actually look at um, the things, you know, it says output, terminate function, determinant, replace column. So it's much more, I guess, professional, and it explicitly states the programming loops, which I sort of just briefly went over in mine, but it very much, you know, like specifies that. Yeah, there you go. And so, yeah, it's much more specific. And overall, while they try to achieve the same goal, it's clear that the AIs is much more, I guess, professional is the what I would say. And that's why ultimately I'm going to use the AI's code in a presentation setting rather than my own code. My own pseudocode would be better, however, in a presentation setting, but I want to maintain a certain level of professionalism. And the AI language model pseudocode is much more in line with the deliverable final project. In addition, it's much more technical. So for a beginner, mine would be easier to understand, but for someone taking the class or someone who's generally more knowledgeable or technical with C programming, you know, it's going to be more useful to read something like this rather than my pseudocode when, you know, it could sometimes sound like I don't particularly know where I'm going with it. So yeah, thank you so much. And here are some references that I use. So Kramer's rule, here's the OpenAI link, and then I had to review some of the matrix multiplying stuff. So yeah, thank you so much.